Alright, here's another quick clip to explain how this donut dolly shrinks. It's working by supporting a crowned surface. It works best on something that has a double curvature. If it's just got a single bend, we can work flats in, but you really have to capture the edge. You have to lock it in so that it doesn't run out in the panel. But on anything with a double curve, even in a fairly low crown, it works really well. And it works by supporting a circular area and leaving the middle open. And when we come in with a round-faced hammer or mallet, the contact point between the center of this radius and the top of that panel causes a three-dimensional shrink. The crown drops down vertically and the panel shrinks in from all sides towards the center. Now I drew this up on a little piece of scrap here that's crowned. You can see this is crowned, and this represents the area that's targeted by the dolly behind it. Now when we hit the center, it draws the panel down. It's pulling from all directions at the same time. And you can see that as the material is pulled in, the area changes, gets smaller and smaller the closer it gets to the center. And if you picture it with these lines here, it's like a series of wedges, and it forces the metal, it wedges itself in and forces the metal to shrink into itself. But it's doing it over such a large area that it leaves very little marking. Even if you're doing pretty aggressive shrinking, the only real crystal regrowth you'll see is right at the very edge of the transition, where it's going from the highest crown and rolling inwards. This is the method for spot shrinking, where you're working on a single shrink, and it acts a lot like heat shrinking with a torch. The second mode, which I demonstrated on this previous part, is running a shrink across a panel. And that starts out the same way that the first one did, working with a radial shrink where you're shrinking down one spot. But then by angling the panel a little bit in relation to the dolly, you are able to run along in one direction, and basically you're going to start out shrinking circular, and then you're going to run in a series of crescent-shaped shrinks in the direction that you're moving, because you're making contact mainly with the leading edge of the dolly here. And as it moves forward, it creates a hollow in kind of a crescent shape, and when you hammer it down, that crescent shape is pushed down and back towards the panel itself, almost edge on, and so it causes it to shrink down and together back into the panel. And if you have it at a fairly steep angle, you do a pretty deep initial depression, and you move the dolly up at a fairly steep angle and move it over just a small increment, you maintain that deep shrink because it's got more vertical room to travel between the leading edge and the trailing edge. Now if you angle the dolly back more flat, it covers a wider area, and so you end up with a much flatter surface, and it doesn't shrink down as deeply into the panel. So that's the two modes of operation there for the donut dolly.